The second advanced topic I wanted to talk to you about regarding Karnaugh maps is this idea of a Minterm expression. Now, Minterm is almost certainly a new word for you, but Minterm simply means that it is a Boolean product, so it is an AND of several variables, and that Boolean product must include every input variable. So if there are three variables, if there's A, B, and C, then A and B and C is a Minterm, or not A and B and not C is also a Minterm. So the variables can be complemented or they can be uncomplemented, but every variable must be present for there to be a Minterm. Now each row of the truth table is a Minterm. If you think about the first row, that's not A and not B and not C. The last row is A and B and C. And since every row of the truth table corresponds to a cell of the Karnaugh map, then every cell of the Karnaugh map is also going to correspond to a Minterm. Now we can number those Minterms as we've numbered row 0, row 1, row 2, and we can also number the cells in the corner of the Karnaugh map. We've done that in every Karnaugh map that we've done in an example so far. And those numbers are the Minterm numbers as well. As a matter of fact, we can have a very compact notation to represent which rows of the truth table or cells of the Karnaugh map need to contain a 1. And all we need to do there is say f of input variable list equals little summation symbol, lowercase m, and then in parentheses, a list of the cell numbers that contain a 1. I think that the easiest way to see that is to look at an example. Here you can see I have f of A, B, and C is equal to Minterm notation, sum of Minterms 0, 2, 3, 6, and 7. Now that equation right there contains exactly the same information as the truth table does, but of course it lists it in a much more compact manner. We can then quickly fill in the Karnaugh map by putting a 1 in cells 0, 2, 3, 6, and 7. So we simply take whatever numbers appear here, we put 1s in those locations of the K-map. Notice, by the way, that we had to specify it's f of A, B, and C, not only so that we would know what the three variables are, but so we know that there are three variables. Otherwise, I wouldn't know whether to write a 2-variable K-map or a 3-variable K-map or a 4-variable K-map. You have to specify what those variables are so that you know how big the K-map can be. Now, once you've filled the K-map from the Minterm expression, you can just group it and write the equation in exactly the same way. So here I'm going to group this group of 4 and then this group of 2. And then when I write the expression that comes from those two groups, I end up with this sum of products expression. So in literally just that much space, we went from the Minterm representation to the Karnaugh map to the minimized sum of products expression. That's really all that there is to a Minterm notation, except there's also the possibility of having don't care entries. If you have a don't care entry, you just have a second term. So you say the sum of Minterms 0, 4, 5, and 8, that specifies what cells contain a 1, plus the sum of don't cares 1, 6, 9, and 10. So cells 0, 4, 5, and 8 have to contain 1s, and cells 1, 6, 9, and 10 contain don't cares. Now, given that we can then fill in the table with zeros for any cell that was not mentioned in either of those two lists, then we can just do the groupings. And in this case, I'm going to group it such that cell 1 and 9 are going to be considered to be 1s. Cells 6 and 10 are going to be considered to be zeros. That gives me two groups of 4, and it gives me this expression to represent what the minimum sum of products expression for this Minterm expression would look like. So you know what cells contain the 1s. Those are the ones that are in the Minterm sum of M. And you know what cells contain don't cares. That's in the Minterm expression with the lowercase d. By the way, if there is no lowercase d, then there are no don't cares. Many times you'll have a Karnaugh map problem that has no don't care cells. You care about every single cell. So if this part is omitted, don't worry about it. That just means that every cell matters. And any cell that's not listed as a 1, by default, that cell will contain a 0. So that leaves you to do the Karnaugh map with Minterm expressions example problem. This is just giving you lots of practice with solving Karnaugh map problems and approaching them in slightly different ways.